I'm going to try it one more time. And pain. Y'all bear with me a minute. Pain. P-A-Y-N-E-S. And it says she's offline. So I've tried 3 times. So you may have. Okay, for some reason, Pendleton and Easley, y'all are dark because this TV, I don't know if this TV is, and I can't do it because there's 2 TVs and the remote. Y'all are dark for some reason, so if I don't see who's talking, it's not because, it's because I can't hardly see them. Anyway, I'm going to finish 7 point, or whatever chapter we on. 11.1, 11.3, you're talking about 33% on each section. And that's going to be your test on Unit 3, because that is the most important sections in Unit 3. When y'all come back after Thanksgiving, we're going to hit polar coordinates. We're going to hit polar coordinates real good. That's going to be Unit 4, and that'll be your last test. Whatever we cover up until the last day of class, which is December 3rd, that'll be what's going to be on that test. So I've got down to, I think, this problem with the...
Can we take the problem? That's fine.
Where is it? There it is. Okay, that's where we left off. And I believe we were starting this problem. And yes, this is, I've got 2 other problems. I looked up a couple of problems out of your homework on this one. So we've got a couple of these. But go ahead and write that down if you didn't write it down before. The ship leaves port.
Our screen is frozen.
Who said that? Pendleton or Easley?
Easily.
Easley? Okay, I'm going to take you out. I need you to X out, and I'll bring you back in, okay? That's the easiest way to fix it.
Okay.
I have a question.
Evidently, they didn't shut it off, whoever was in there before. Did y'all say something, Pendleton?
I have a question.
Yes, ma'am.
Are you reopening the homeworks?
I thought I reopened them.
They were all due the 19th.
I thought I opened them for, I will, but I thought they were open for the whole, I thought they were opened. Are they not opened?
No, sir.
Oh, I get so sick of this. Okay, all right, I'll fix it. Let's just worry about this problem right now.
Okay.
Wait a minute. I'm trying to do 2 things at one time. There's Miss Payne. I was beginning to worry about you.
Hey.
All right, let's pull in Easley again.
Yeah.
Okay, Easley, hopefully you'll be able to see it now. They'll come in eventually. I'm still waiting on Easley to come in. I don't want to start until they get in.
We're in.
I know, but I don't see you. Turn your camera on, please. And I can't make this big. I don't know why this is not working. Something's going crazy. This thing's blinking like crazy. What in the world's going on?
I don't know why it's not.
Okay, Easley, where are you? There they are. Okay, I think we got everybody now. Okay.
I don't know.
A ship leaves port on a bearing of 28 degrees and travels 8.2 miles. So go ahead and write all that down. I'm still trying to get y'all fixed. It keeps shifting on me for some reason. I don't know why. There. A ship leaves port on a bearing of 28 degrees. Now, notice, bearing. Bearing is off of what direction?
What you're leaving from?
Off of north. Bearing is off of north. Remember, these questions are not going to give you every little single detail. You're going to have to pull it out of it. When I say due east, what does that mean? That means you're on the horizon. Due west, that means you're on the horizon. If I say a bearing, that means it's coming off of north. Okay? Now, I don't know how many people of you, I don't know how many of you have had this kind of trig before. I don't know how many of you have had land navigation courses before. Of course, I know some of y'all invented both. But in some cases, people don't realize that the bearing is off of north. And we talked about that in Unit 1, and I just wanted to remind you of that one little piece, okay? So that's why you've got a bearing of 28 degrees off of north. Now, since that bearing is 28 degrees, what's this angle right here? Well, that angle is going to be 90 minus 28, which is what? 62? So this angle is 62 degrees. Therefore, this angle is 62 from 180. Should you be doing that at the beginning of the problem? Yes. And now you have a good amount of information to where you can actually find PE, because this is what you're finding. You're finding that side right there. And it looks like to me you got an angle. You got an angle here. You've got a side here. You got two other sides. You want this side. Looks like to me you're going to use the law of cosines. I'm not sure, but that's what it looks like. And that's what they're wanting. And they've already done the 28 degrees and the 62 degrees, 118 degrees. So we've basically filled out all the degrees that we can fill out. And they're probably going to use, okay, they use the law of cosines. Plug those in. Now, I'm not going to plug them in for you because I think most of y'all should be able to plug those in. I wish that I could. They used 8.2 and 4.3, so let me go back. 8.2, I'm going to highlight. They used 8.2 and 4.3 and the 118 to find that right there. So A, I guess you'd say A. There you go. And of course, you found now once you find the magnitude of that vector, once you find the magnitude, you can plug it into the law of sines, if they even asked you for that. There you go. Now, it's pretty easy when you're given the drawing. So now I've got a couple of problems that I pulled out that I liked, and we're going to do those. Question, gripe, complaint. Does everybody see what to do? Now in this case, you didn't use the dot product, you didn't use any of that, because that's more, the dot product and all that good stuff is stuff you're going to see later on. As far as the application problems in 11.3, they're pretty much going to follow along the lines of law of sines, law of cosines. Does everybody understand that?
Mm-hmm. Yes, sir.
Okay, one person understood it. I'm glad. Thank you. So let's go to the handy-dandy whiteboard. And let's let you... When that pisses me off. Okay, just wait. There's something going on with my computer. Every time I touch something, it flickers, and it's the Russians. See, it does that. That's what it does. So I'll just wait until it quits doing that, and hopefully, see, it's doing it again.
Let's just give him time to write it all down.
Let's just quit, right?
No. It was just giving me enough time to write it all down.
Okay, well, that's good.
Should have a quick trip.
I don't think I'm going to be able to do anything because for some reason I'm still flickering. Okay, we'll just. Okay, I'll tell you what I'll do. I'll just hit this, I'll hit that, I'll hit this. There we go. More than 2 ways to skin a cat. All right. We have a boat due west. Boat is due west at a speed of 30 miles an hour. If there is a 7-mile-per-hour current, at north 30 degrees west, find the speed and direction of the boat. Okay, I'm going to let y'all have a second to work on it. And this is a test question, just like the one we just did. I've got 2 of these, and I've got 2 or 3 force homework problems. I'm going to give y'all, let's see, it's 11:32. I'm going to give y'all a couple of minutes to work on that. First of all, you're going to draw what?
Triangle.
You're going to draw a picture, yes. I would probably suggest draw 2 pictures. One picture the way it is, and then put the vectors head to tail to get the triangle. But that's just me. Did you see that? I just made this window big, and it just decided it wanted to. Do it again. I wouldn't have to do this if they'd have put the piece beside each. I asked them. Hey. Well, I told them put one on this side in the corner of this and one over there and just have them go across like that. And I did that.
This is north. This is west.
West. We.
Go ahead. So north, 30 west. What?
So y'all probably don't need too much longer with this.
Yeah, but we don't know what to do.
I'm sure your calculator can tell you how to do it.
So north 30 degrees west means 30 degrees off of your northern axis, right?
Northwest means yes. So it'd be 30 degrees off the north axis, but it'd be in the left direction. That's giving you several minutes, at least to draw a picture. And I'm going to draw a picture. I'm going to use black for the graph. So I'm going to put a graph right here, like that. And then I'm going to use a red vector for the boat is due west, speed of 30 miles an hour. So that would be that vector. And then we got another vector, and I'll do it in blue. And it's at 30 degrees northwest. And I'm drawing them thick so y'all can see them. Okay? And that's 7 degrees, sorry. 7 degrees, or 7 miles per hour, and that's 30 degrees. So you basically have a picture of a triangle put head to tail. And this is your free body diagram, if you want to call it that. And then blue, like that. So your resultant vector, I'll do in per day, is right there. Now again, I'm not teaching those students that invented physics. I'm teaching those students that have never done this before. All right? All I did is I took that blue one and I put it right here. Now, of course, I made it shorter because 7 is less than what? 30. Okay? So I made it shorter, and now I've got to figure out, I don't have enough information to go off of. All right? So what I'm going to do is I'm going to use my r sine theta, r cosine theta. So I'm going to use, here we go. We got this right here. We got a r cosine theta. So if I want the red, I'm going to do it in red. I'm going to get my vector for r cosine theta. We know that the cosine is the x. And of course, this is pretty simple because it'd be 30. But we're going to go ahead and do it anyway. R cosine theta, r sine theta, and that will give us 30 cosine of 180, 30 cosine sine of 180. And right now, those people that, never done this before will type that in your calculator. And I got, I just went ahead and wrote them and then I added them together. I basically came out with, let me go ahead and do this one up here. 7, this one would be 7 sine or cosine theta, which is 30, and 7 sine theta. And crank those out. And somebody tell me what you got for 30 cosine. Well, think of it. On the unit circle, somebody tell me, I'm going to use the black. What is the cosine of 180 degrees? Out here, we know this is -1 comma what?
0.
0, right? So what is 30 times -1?
-30.
-30. So I'm going to get -30 right here. And what's 30 times 0?
Zero.
And anybody looking at the vector could say, oh, that's negative 30 and 0. But what if it's not 0? What if it was 5 degrees? If it was 5 degrees off of the west vector, then of course you wouldn't know what it is. You'd have to, do the cosine and sine of 5 degrees, or whatever the case may be. So what do we get up here in the blue? Somebody take 7 times the cosine of 30. What do you get? Just give me the decimal. I don't want no radical.
6.1.
I'm sorry, what?
6.1.
6.1. And then what is 7 sine of theta?
3.5.
33.5?
3.5.
3.5. Now you have a x and a y to these vectors. Okay? You have an x and a y to this vector, and you have an x. I can find the magnitude. Okay? The magnitude, the r vector, is negative 33.5 and 6.06, which is going to be 6.1. So that's going to be your r vector. If you add those together, you're going to get the r vector, and I'm going to do this in green. R vector is equal to, and that's going to be negative 33.5. Somebody check me. And you already got 6.1, so that's going to be 6.1. That's going to be, now, if somebody plug that into the Pythagorean theorem, and you get R, or you get the magnitude of R, is equal to the square root of negative 33.5 squared plus 6.1 squared. And somebody do that in your calculator. And of course, I can't move this. There we go. Somebody tell me what you get. Of course, it's going to be positive. You ain't got to worry about the negative.
34.
I think I got 34.
34.1.
Okay, 34.1 is good. So the magnitude of that vector is 34.1. So R is equal to 34.1, and that's miles per hour, I guess. Now I want you to figure the angle. Figure the angle, because now you've got, hold on, I made a mistake. I didn't follow my notes. Hold on 1 second. That's not, I saw something wrong here, and hold on. Well, it's not 30 degrees. Hold on a second. It's not 30 degrees, it's 120 degrees. Plus 90 is 120 degrees, so change that to 120 degrees, my bad. What happens when I don't follow my notes. 120 degrees and 120 degrees. Okay, somebody do 7 cosine of 120.
It's negative 3.5.
There we go. Negative 3.5 and 7 sine of 120. What do you get? Should be 6.1.
Yeah, 6.1.
There we go. Thank you. All right, so now you add those two together. What's negative 3.5 plus negative 30? Negative 33.5. And what is 6.1 plus 0? 6.1. So that's how you got the R vector. Okay? Now I want you to figure the degree of this function, or find the direction of that green vector. You don't have to find the tan. I'm sorry, you don't have to find it. I'm sorry. This question is not designed to find the. You got to use the dot product, and we're not ready for that yet. So just find the magnitude. My bad. Find the magnitude, which you just found 34.1. Okay, this one you're going to find the direction as well. Yeah, this one you're going to find the direction. So I'm going to erase this, and we're going to do another problem. Everybody got this one? Yes or no?
Yeah.
Yes.
Most of you have it, okay? Let me erase this one. And let's do another one. This one has an airplane. Airplane speed of 520 miles per hour. Bearing of 260 degrees. If a wind is blowing at northeast from north 30 east, yeah, as the wind is blowing at north 30 east, not from, sorry, there's a difference between the two. At north 30 east at 60 miles per hour, what is the result speed and bearing of the plane? What is the speed and bearing of the plane? Now, you could find the bearing of that last question with the law of cosines or the law of sines. I just did it, and I did it with this one. I'm sorry. What is the speed and bearing of the plane? So draw a picture first. Now remember, the bearing is coming off of north. Somebody posted on Facebook, I heard from a guy who heard a phone call from someone that felt bad about another person's assumption that DHAT had Russian dressing for lunch.
You what, mate?
Some of y'all don't even understand it, right?
No.
Sad.
I mean, that's it. 260. That's 10. 520. North. 30 degrees east. 60 miles an hour, 30 degrees. That's 60 degrees.
Are y'all actually talking about the problem? Wow.
Yes.
I'm not used to that.
Ouch.
I'm used to y'all watching Hulu on laptop. Oh, I'm sorry. It's not Hulu. It's Netflix. It's Disney now, right?
It's Disney Plus.
Yeah, Disney Plus. Yeah.
I'll do that in this class.
All right. So here is our graph. And I'm going to draw the airplane. I'm going to draw it in blue. The airplane is going 260 degrees. Well, this is 270 right there. So 260 would be right in here. So we're going to draw that 260 right there. So 260 means that this angle right here is 10 degrees.
So with the bearing, you're always going
Off of what?
north in a clockwise
Off of
direction.
north. Yes.
Okay.
Off of north, always.
Oh, I did that wrong.
If a wind is blowing at north 30 degrees east, north 30 degrees east, I don't know why I just did that, but just took off on the left side, just 30 degrees east. So I've got to put those two together. So when I put them together, it's going to look something like, hold on, blue. I'm going to draw a line that looks like this. And of course, that's 200 or 520. And we know this angle is 10 degrees, but that's off of, I'm trying to just draw a horizon there. We know that's 10 degrees. Don't know if that's going to help us any or not. And then we got a 30, which is just a small little vector. That 30 is going in this direction. That's 30. And we know that if we drew a horizon, not a horizon, but a vertical here like that, we know that was 30 degrees right there, or whatever. Oh, 60. I'm sorry, 60. I don't know why I don't pay attention to my notes. 60. And we know that this right here is 30 if we need it. Okay? So the resultant vector is going to be a vector, and we'll do it in green, is a vector that's going to be going like that. Now somebody tell me something about that vector. Just by looking at it, what is that vector doing to that 10 degrees?
Making it smaller?
It's going through it, right? So we know that the position, the green vector is going to be less than 10 degrees as far as its position to the origin, right?
Mm-hmm.
Because it's bisecting it. So that's a common sense question that you need to be putting in your head. Okay, my answer is going to be less, maybe 5 degrees or something. My answer is going to be, instead of 10 degrees, instead of 260 degrees, it might be what? Back 5 degrees, 255 degrees or something like that. So you need to be thinking about that. So I need you to take your drawing now. I need you to blow this up. Okay, you need to blow that drawing up a little bit. So I'm going to go over here and I'm going to erase that drawing. And I'm going to make this drawing a little bit bigger. And until you start learning this stuff, you better be drawing some good drawings. Mine suck, but hopefully yours don't. There's that one. And then the one's going up like this. And then the green one going like that. And we got 520 and 60. I love how that magenta turns purple. Now, you can actually, going to be actually able to find your angles using these horizons that I told you about. Okay? Some people call them Z horizons, some people call them, I'm going to do them in black. All right? This horizon right here tells you that this degree is 10 degrees. So what's this angle? 10 degrees. Alternate exterior angles. Now I didn't say the angle to the green, the angle to the blue. If that's 10 degrees to the blue right here, if you put a horizon down here, then that's what? 10 degrees. We know that, let's see, 30 north, 30 degrees. Yeah, that's right. Okay, work on that for a second.
So wouldn't that make the angle inside of that, wouldn't that make the angle where the 520 and 60 meet, just 90 minus 40?
90 minus 40 would be 50, yes. How did you get that? God, I'm not believing that. How'd you get that? Because the
your northern
purple
horizon is 30 degrees.
Good job. Thank you. That was my next step.
Yes.
Look at your vertical. Remember me putting that vertical right here? And I told you that this 30 degrees right here would come into play. And if you got 10 degrees right here, what's this angle in the middle?
50.
50. So that degree, so I'm going to put that in light blue. This angle right here is 50 degrees. Now you've got an angle. So now you can use the law of cosines. So use the law of cosines. And I'm going to put it in black because I'm probably going to be finding this angle up here. Yeah, because I'm coming across from this one. Yeah. So I'm going to erase this now. And what I've got is I've got sunshine. Well, R squared is equal to 520 squared plus 60 squared minus 2 times 520 times 60 times the cosine of 50 degrees. Now, I need somebody to crank that out for me. I got the answer, but I want to see what you get.
483.6.
It's a miracle. 483.6. Pendleton or Easley, check that, please.
Oh.
So R, this vector, the magnitude of this vector is 483.6. Oh my gosh, now we can use the law of sines. Or, use the law of sines. Let's see, we got we're looking for that angle up there, so we'll call that angle X. And then over 60 is equal to sine of 50 over 483.6 or something like that. Did y'all get 483.6?
Yes.
Okay, I appreciate y'all confirming that for me. Yeah. After I asked 5 minutes later. But that's okay. Appreciate it.
I'm sorry, I missed
That's all.
3 times.
You were checking it?
Yeah.
All right, now, I'm going to do this in black because you'll be able to see it better. I'm going to find this angle right here. I'm going to color it right there, X, between the green line and the blue line. So the side across from that is 60. So 60 over the sine of X is equal to, and I'm going to use our angle right here, and that's 483.6 divided by the sine of 50, cross multiply, so that's going to be 60 times the sine of 50 divided by 483.6, and do the inverse sine of that, and somebody give me what you got.
I got 5.5.
5.45 is what I got. 5.45 degrees. Is that your answer?
No. Yes.
No. It is
No.
not your answer. Remember, what is the plane coming off of? The plane is coming off of north.
Yeesh.
So you've got to find out what that bearing is. You can't just say 5.45. You run into a mountain or something. You got to say what's coming off of north. So you know that this right here is 2 what? Or let's see, that's 260 right there.
Yeah.
You know this angle is 5 whatever. Okay? Or now you can do it 2 ways. You can add it to 260, or you can subtract it from 270. Whichever one, I don't care which one you do. But I get 265.45. That's your final answer. So I'm going to write in green, I'm going to say at a bearing of 265.45. Now remember when I told y'all that when you're doing these problems, you have to read, okay? Bearing. Bearing tells you off of what? North. Okay? If I say that it's moving directly east or directly west, what if I tell you that a wind is coming out of the southeast?
Hey, not to interrupt you, but I think it would actually be 264.55, wouldn't it?
What?
You're taking 270 minus the 5.45, right?
I did 270 minus 4.55. Or you could take 260 plus 4.5. You could do either way. Your final answer should be 265.45.
No.
Wouldn't it be, you're saying minus or plus 4.45, but we got 5.45.
Okay.
I mean,
You can do 270 minus 4.55, or you can do 260 plus 5.45.
oh, okay.
What
Both
did you
of
get
them will
for
come out the
R?
same. Yes.
Excuse me, what do you have in your notes for R?
483.6, what we have right there.
Okay. I got something different when I tried it twice. I don't know. It's something I'm doing wrong.
Well,
I'll
we
figure it out.
did, okay, 520 squared plus 60 squared minus 2 times 520 times 60 times the cosine of 50.
I'm getting 493.96 for some reason.
Check to make sure your calculator's in, and also check to make sure it's in degrees, and check to make sure that your decimals are floating under mode. You may be rounding in there. Try it again when just go to mode.
It's to
What?
8, the 8 decimal. My float's to number 8.
Well, make sure it says floating. Hit floating. And try that.
Okay.
Amanda, did that help you? Do you see what I'm talking about? You still get the same answer.
I'm confused though why you would subtract 4.55 and like wouldn't you use the same number either way whether you're adding or subtracting?
Okay, you know this is 10 degrees right here. Okay? If you take that 10 degrees and you subtract 4.55 or 5.45, you get 4 point what? 4.55. Okay. And you can subtract that from 270.
Okay, I see. Yep.
And then if you don't want to subtract from 270, you just add 260 plus this 4.55 or 5.45, whatever, this right here. And you can get, both of them will come out the same way.
Okay, that makes sense.
It's kind of like if you go to Greenville, if I go to Anderson to Greenville, I can either add the mileage or I can subtract for Greenville from Anderson. You still get the same miles. Okay?
Sure.
All right. Now, let's do some force problems. I had another one, and I think it's this one. Oh, my question is this. What would happen if I told you that a wind was coming from the northwest?
I'm 9 words away.
What would you say if I told you that a wind was coming from the northwest?
Wouldn't it be going in the southeastern direction?
Exactly, but what degrees would it be?
It would be. What do you mean?
What would a southeast wind coming from the northwest, what would the degree be assumed?
Should be 15.
I guess it would be between
45.
45 degrees, because half of 90.
Oh, okay.
And see, that's an assumption in navigation. I'm trying to get y'all to understand that sometimes these problems assume that you know a certain amount of information. So let's go to this problem. And this is the last navigation problem. You're going to have two type problems for 11.3. You're going to have a navigation problem, and you're going to have a force problem. And you're going to have dot product and all that stuff that we did. Okay? And you're going to have your notes, so it's not going to be that big of a deal. So here is the problem. Now this one is a problem that you're going to have to think a little bit. Plane.
I don't like thinking.
I know. Heaven forbid I raise the bar. Plane needs to head north. Speed is 250 kilometers per hour. There is a strong headwind. (75 kilometers per hour) from the northwest. What is the plane's direction and speed to head north. Now, y'all know what fishtailing, smokestacks, jacked up trucks, and Carolina squats are for, right? The overcompensation. So when you're dealing with a headwind or a tailwind, what do you have to do if you're a pilot or driving a boat or whatever? You have to compensate for the headwind. Am I correct? Yes or no?
Yes.
Yes. Okay, so your goal is to head directly north. That's your goal. That's what's your answer. This answer is which direction do you have to speed, do you have to go to find the goal of the going which way?
North.
North. Now, it says that a plane needs to head directly north. The speed at 250 kilometers an hour, there is a strong headwind. All right? Now, I don't know if I didn't write the problem down right, but it basically said that, yeah, that's all it says. It doesn't give a direction for the plane or anything. Yeah, it don't give a direction. So, you're going to draw a picture basically of a plane. You know it's heading either northwest or southeast. I mean, it's either heading northeast or northwest. But since the plane is coming, since the headwind is coming out of the northwest, we're just going to draw it like this. There's the plane. Now, that's exaggeration because we don't know what theta is. We don't know which direction the plane is heading. So we kind of put an X right here because we don't know. We know that the magnitude of the plane is 250. And then we know that a wind coming from the northwest, which means it's heading what? Southeast. That's the wrong color. Southeast. And I'm going to draw a little do-jigger right here. And I'm going to put 45 degrees right there for you. And we want to know, and that's supposed to be north. It's supposed to be hitting this north arrow. I'm sorry. I didn't draw it right. But your picture is going to look like this. I'm going to draw the north arrow first. There's the north arrow. And then I'm going to draw a green arrow like this. Like that. And then I'm going to draw a blue arrow. And that'll make more sense to you. There you go. So that's what it's supposed to look like. And we're going to find this angle right there. Right here is the angle we're going to find. And we know this is 250. And we know this has got something to do with 45 degrees. And we know the magnitude of that is what? 75? Now, the good thing, something else you know, north is always going to be 45. North is always going to be perpendicular to east, right? Everybody knows that. So, I'm going to draw a little horizontal right here. And that's supposed to be the north arrow. That's going to be 90 degrees for east. And alternate interior angles, this right here is 45 degrees. So that angle right here is going to be 100 and what? 135 degrees. I didn't do the best work there, but I'm sorry. If you put a right angle right here with the east-west line there, okay? what does that make the green line? The green line, if this is 45 degrees up here, what is this down here? This is a horizontal. What's this angle right here? 45 degrees. So 45 plus 90 is what? 135. So now, one more up here. If you drop a plane right here, I mean a vertical line right there, no, we've got to find that angle. I'm sorry. We've got to find that angle. So now we can use the law of cosines because we've got a 75, we got a 135, and a 250. So now we can find the angle. We can find this angle down here. Find that angle.
Where is the 75 degrees? Is that in between the horizon?
75 is that's the magnitude.
What is that? And that's 40.
Yeah.
Oh, that's okay.
The 45 degrees, I can't draw it in there. I tried to draw it, but the 45 degrees is in here, right there. Because of alternate interior angles. I need to draw a bigger picture. I'm sorry. Let me see if I can draw a bigger picture. Because it's very important that some of you see this. That's why sometimes it's kind of hard to draw stuff on this board. Okay, let's draw it like this. 250.
I'm gonna get your pounds.
Like that.
So it's not even funny. So your server is
We
funny.
got the green one coming down like this. I'm trying to draw this to where the north arrow will be straight, but you'll have to use your imagination. There we go. That's north. Okay, now draw your, I'm going to draw these. Here is your plane here. Not plane like flying a plane. That's the horizontal plane. And that's the vertical plane. This is the horizontal plane. And this is the vertical plane. Now, we know that this angle, this green angle right here, is 45 degrees. If that angle is 45 degrees, then this angle is what? 45 degrees. Alternate interior angles. If that angle is 45 degrees, what's the angle between the horizontal plane and the vertical plane? What is that angle? That's 90 degrees. So this angle is 100 and what? 35 degrees. Does that make sense now with y'all?
Yeah. I thought the 75 was an angle.
Yeah, 75 is the magnitude. So, with that being said, sine of x, right here, delta x, I don't care, over, what's across from that? 75? 75 is equal to 13, we got 250 right here, sine of 135 over 250. Somebody crank that out, and you get 75 sine of 135 divided by 250 inverse sine. I get 12.2 degrees.
12.2 degrees.
Second.
Now you can also find this one. This is going to be 32.8 degrees if you need it.
12.2. Symmetry.
Really?
And now you can find the magnitude of this angle, of this black line. So the magnitude is going to be c squared equal to 75 squared plus 250 squared minus 2 times 75 times 250 times the cosine of 32.8. And that will give you the magnitude of this line. So the magnitude, I get 191.3. So basically, in order to fly directly north, he's going to have to make a change in his angle of 12.2 degrees, and he's going to have to fly at 191. He's going to have to change his course, his magnitude, 191 miles an hour, or kilometers per hour, or whatever the case may be, to make up for this what? For this headwind. Does everybody understand? He's going to have to change his, so if he's heading 100 degrees northwest, or I don't care, whatever you want to call it, then he's going to have to back off and go 87.8 degrees and go add 191 kilometers to his what? To his speed. All right, that's your 3 directions. And of course, I know you're going to send me some problems when we do homework problems next week. So I know that. All right, before y'all go into convulsions, I don't know what time it is, but let's see. It's 12:22. I forgot when is class over. So I got time to go over one right quick. So let me delete this. And here is a force question.
I love force questions.
Takes a force. It takes a force of 25 pounds to keep a box from sliding down a ramp at 21 degrees. How much does the box weigh? And what does the box have in it? What does the box have in it? No, I'm just kidding. How much does the box weigh? It's a case of Jack Daniels.
Okay, so about 3 pounds.
What?
So about 3 pounds.
Oh, yeah. Right.
Oh. So you got to draw a ramp. There's a lot of assumptions in here. And these are the assumptions that go with a force diagram. One assumption, that your ramp is coming off of the horizon. So your ramp is going to be at how many degrees? 21 degrees?
Yes.
Now that 21 degrees is going to show up somewhere else. So here's your box. Your box is up here. And when you draw a box on a ramp, there's going to be three forces exerted on that ramp. There is the law of gravity. The law of gravity is going to be perpendicular to this horizon. That's one assumption. So you put gravity, and we'll put gravity right there, and it's always perpendicular to the horizon. And we'll make a purple line, and this is the force that the box exerts on the ramp. And that force is always perpendicular to the ramp. And guess what that angle is in the middle?
21.
21. Somebody paid attention in physics.
I took it for 2 years, so yeah.
Oh, good job. Now,
Really tried.
there is another force, and that is the force that is keeping the box from sliding. And we'll do that in magenta. And that force is going to be parallel to the ramp, which is always going to be parallel to that line. Because the green line is perpendicular to the ramp, this line is perpendicular to the green line. And now we transfer. We know that this right here is 69 degrees. Put that in there. I'm trying to draw this in different colors. I don't know if it's working or not, but this right here is 69 degrees. Now, is it always a good thing to fill in any angles that you don't know if you can? Yes.
Yes.
All right. What's 21 from, what's 21 from 90?
79.
I heard 1700. What?
79.
Thank you. So this angle right here is 79. Now, I also know that that purple line, I'm sorry, it's supposed to be magenta. It's magenta in the box, but when I write, it's purple, so it's conspiracy. If that line is 25, then this line is 25. And now, you have pretty much all you need. You got the 21, you got the 25, you got the 79. I believe you can use the law of sines. You can also use the actual trig function, okay, if you wanted to. So I'm going to go back to black, ACDC, and that would be sine of theta is equal to Oscar hat. Okay, wait a minute, Hubert. What do you mean? Well, your little man is where? Your little man is up here because that's the only angle. Well, you can use any angle, but I used 21. So my little man is up here. So he has 1 foot on the what? On the adjacent and 1 foot on the what? Hypotenuse. Oscar had. No, I'm sorry. Oscar, right here. Oscar. Whew. So that's going to be sine of 21 is equal to 25 over what? Oscar had, that's going to be your hypotenuse. So multiply both sides by 25. Both sides by h. So h is going to equal 25 divided by the sine 21 degrees. When y'all crank that out, should y'all get 70 feet or 70 pounds or whatever?
Yes,
69.
Point.
Yeah.
So that box weighs 70 pounds. Well, that's a good question. All right, let's do one more. I'll put it on the board, and y'all can do it at home.
I'm going to take a snip of that real quick if you don't mind.
Okay, then we'll do it later. We'll do it Tuesday. Y'all get out of here and have a good weekend.
You have a better one.
I'll try. I don't even know who's playing this weekend. I know Clemson's probably playing a high school. Who's Clemson playing this weekend?
Yeah, bye-bye.
Nobody.
All high schools are booked up.
Who's LSU play? LSU plays Georgia, don't they? No. Hey, is this rival weekend? Pendleton,
No,
make sure you X out of the
Next,
program, please.
oh well.
Pendleton
Next
was
weekend.
left. Okay, thank you. I think this is rivalry weekend, is it not?
Next
Weekend is.
Next weekend.
Well, who does Clemson play this week?
They're all.
Nobody.
Not
We have a
playing
bye.
Huh. Well, they don't have anybody else to play except for the round. They got South Carolina, which is going to be pitiful.
Goodbye, Mr. Hubert.
I just tried to push.
Hubert, did you get
Yes,
my
ma'am.
text yesterday?
I'm sorry, what?
I said, did you get my text yesterday?
I haven't gotten any text. Something's wrong with my phone. I think there's something wrong because my son's not getting them either.